Hello students, good morning. This is the part 9 of our chapter Work and Energy. In this part we will discuss about the transformation of energy and also see various situations in which very often energy get transformed from one form to another. So first let us try to understand what does transformation of energy means. Transformation of energy. So students, transformation of energy is defined as a process in which there is a conversion or changing of energy from one form to another. So we can say it is the process of changing of energy from one form to another. So in simple words we can define the transformation of energy as changing of energy from one form to another. Okay, now let us see some examples from your surrounding in which very frequently energy is changing. For example, when you eat food, then during digestion, when the food is breaking down, then what happens? The chemical energy is released, and that chemical energy is stored in the form of muscular energy in your body. So here in this process, we have seen that the chemical energy of food, the chemical energy is converted into muscular energy in your body. With the help of which you are able to do some work, muscular energy. Okay students? When you turn on the electric fan, then what happens? The electrical energy that you are supplying to the fan is getting converted into mechanical energy. Why I am saying mechanical energy? You know, mechanical energy is the sum of kinetic energy and potential energy. Since the fan is rotating, it means it has certain velocity. If it has velocity, then we can say it has kinetic energy. Also, the fan is fixed at a certain height. Okay, if it is fixed at a certain height, then it must has potential energy. It means the running fan has both kinetic energy as well as potential energy. So we can say it has mechanical energy. So what we can prove? The electrical energy is converted into mechanical energy. Okay. When you turn on the electric bulb or the tube lights, then what happens? The electrical energy that you are supplying, or that the electrical energy that is supplied to these appliances is getting converted into the light energy because it gives some light and also heat energy. So here in electric bulb we can say the electrical energy is converted into heat and light energy. Again students, there are numerous examples in our surrounding in which very frequently energy is getting transformed or changing from one form to another. Now we will take some examples to understand how the energy is transforming in these cases. The first example we take when a stone is thrown upward and returned back to the thrower. So first let us consider this situation. Now students, let us consider this example. A stone is thrown upward with a velocity v and returned back to thrower. So there are two motion. One is for upward motion and second is for downward motion. So this is the figure for upward motion. This is the figure for upward motion, and this is the figure for downward motion. Okay. Now students, let us suppose this is the ground level. This is the ground level from which a stone of is projected upward with a velocity v. This is the initial position when the stone is just thrown upward with the velocity v. So at this position here, you can see the stone has acquired no height. The stone has acquired no height. Since it has acquired no height, so we can say the potential energy here EP equals to 0. Because we know potential energy possessed by a body when it is raised to a certain height from the ground level. Since at this position A, the stone has no height, then we can say the potential energy is 0. But again, this stone has certain mass and it has the velocity with which it is projected. So at this position we can say the stone has maximum kinetic energy. That is, here stone has kinetic energy maximum and it is equals to half mv square. Half mv square. Okay students, is it visible? Half mv square. So at this position A, the stone has maximum kinetic energy half mv square but no potential energy. Now students, what happens when the stone reaches at the maximum height h, that is at position C, then we can say the stone has acquired the maximum height h. Since it has acquired this maximum height h, hence at this position C, the potential energy will be maximum. So we can write EP is maximum and it is equals to mgh. But what will be the kinetic energy? You know, when an object reaches at the maximum height, then its velocity becomes 0 at the maximum height. So here we can say velocity is 0, and if velocity is 0, then kinetic energy will be 0. Now students, what you observe in this situation? At this position A, the object or the stone has only kinetic energy, no potential energy. But when it reaches the maximum height at position C, it has only the potential energy but no kinetic energy. It means we can say the kinetic energy at the position A get transformed into the potential energy at the position C. So there is a transformation of kinetic energy to potential energy. If we consider a position in between these two positions, that is position B, then here you observe that the object has certain height. Let us say the height is h1. If the height is h1, then we can say it has potential energy, and this potential energy will be equal to mg into h1. Also it has some velocity. If it has some velocity, then it must have kinetic energy. Let us say the kinetic energy will be m into v1 square. So at this position B, we observe that sum of the kinetic energy out of this total kinetic energy half mv square, sum of the kinetic energy gets converted into potential energy. So in this whole upward journey, there is a transformation of energy from kinetic to potential. So we can write here, for upward motion, there is a transformation from kinetic to potential. Now consider downward motion. Now students, the position C represents that the object is at the maximum height or the stone is at maximum height h from the ground. Okay. Since it is at maximum height, then it must have the maximum potential energy. So here we can write at this position C, the potential energy will be maximum EP max and it is equal to mgh. Again there is no velocity. At maximum height, you know, velocity is 0. So if velocity is 0, then kinetic energy will also be 0. So here Ek equals to 0. That is, at this position C, the stone has only potential energy. Now when it starts moving downward, then there is a force of gravity acting on it, and due to that force the velocity is going to increase as it coming towards the ground. The position A represents the position of the stone just before touching the ground level. And when the stone is at a position just before touching the ground, then it has maximum velocity. If it has maximum velocity here, then we can say at this position A, the object has maximum kinetic energy because of maximum velocity. And that kinetic energy will be half mv square. Again, the stone is just about to touch the ground, so we can say the height is negligible or height is nearly equal to 0. If the height is equal to 0, then it means potential energy will be 0. So here the potential energy will be equal to 0. So what we have observed in the downward motion, at this position C, it has only potential energy, but at this position A, when it is just about to touch the ground level, it has only the kinetic energy. So there is a transformation from potential to kinetic energy. So what we can write in this process? There is a transformation from potential to kinetic energy. If you consider a position in between, then here it has certain height. Let us say the height is h2. So the potential energy will be EP equals to mg h2. Again, it is the position in between the maximum and minimum. So we can say it has certain velocity. Let us say the velocity is v2. Then kinetic energy will be half mv2 square. It means sum of the potential energy. Out of this potential energy, total potential energy mgh, sum of the potential energy get transformed into kinetic energy. So students, in this process you have observed that for upward motion there is transformation of energy from kinetic to potential, and for downward motion there is transformation of energy from potential to kinetic. Okay students?